Before we get into the exciting world of active firefighting, sprinkler systems and control systems, I first want to show you a small picture. And of course, it's a fire. And this fire turns out to be a test setup in a railway tunnel, and it's used to test a automatic activated sprinkler system. Well, you see, firefighters are standing by in case something goes wrong, and they're waiting for something, and there it comes. The activation of the deluge sprinkler system. Now, as you can see, it releases, in this case, a lot of water. Depending on the type of tunnel, and I'll get there in a moment, it's between 10,000 and 14,000 liters a minute. And that's a lot. And of course, it's obvious that if you would use that much water to mitigate a fire, it's not possible to activate a sprinkler system for the entire length of the tunnel. You have to be precise and create sprinklers around the location of the tunnel. And that brings us to the subject of my presentation, the activation of sprinkler systems. Now, to get some more background, I'm going to take you to the Netherlands, to the Betuwe Route. I'll introduce you to that system over there. The active firefighting systems in the tunnels. We'll talk about some design consideration and system layout. And of course, I'll talk about detection and activation, the basic principles of what we did for detection, error, and correction. Now, already this morning there is some discussion about automatic activation, and maybe even the question is correct automatic activation, if it's possible. And I hope to answer that question at the end of this presentation. First, we go to the Netherlands in Europe, and we go to the Betuwe Route, and that's the name of a relatively new railway infrastructure, which connects the harbor of Rotterdam on the, you see, on this side of the Netherlands, and Rotterdam is actually the biggest harbor in Europe, and it connects the harbor of Rotterdam with the European mainland. And for doing so, this railroad runs from the west side of the country, near the North Sea, up till the German border. Now, knowing the Netherlands, you would ask, why tunnels? It's as flat as a pancake. But it's very densely populated, especially in the area surrounding Rotterdam. It really is very densely populated. And being the river delta of Europe, we also have a lot of waterways, so many rivers to cross. And that's actually why we end up in a railway connection of only 160 kilometers with 5 tunnels. And these tunnels vary from half a kilometer, a very small one over here, Tunnel Giese, up to 6.5 kilometers, the biggest one here, Rotterdam. And the film I showed you is from the Zevenaar Tunnel, which is closest to the German border. Now, it's important to know that this railway connection is only used for freight trains. Why is that? Because it defines actually the scenarios and the profile of incidents that may occur. The systems, the safety systems and firefighting systems that are introduced in these tunnels are specially designed for pool fires and fires of hazardous goods. And there is no focus on evacuation scenarios, because on any time in these tunnels there will hardly be any people present. Now, what do these systems look like? As I said, active firefighting system, 4 major components. It's the deluge sprinkler system that was obvious already in the film you see. A longitudinal ventilation system. I stick with ventilation if you don't mind. A temperature measurement system, and a control system that will act upon the temperature from the measurement system and will activate sprinkler and ventilation. Now, if we zoom in, sprinkler sections, 30 meters, as you can see here. And if you look at the photo, these sprinkler sections actually have 3 pipe strands. Each have about 11 sprinkler heads, so a total of 33 sprinkler heads within a section. Obviously, ventilation, and the sprinkler strands are connected through these pipes to what we call the valve cabinet, and the valve cabinet is used to activate the sprinkler sections at a specific position. Sprinkler water is through the sprinkler distribution system, which is behind this concrete barrier within the path. We actually use a premix, so water and a 3% AFFF. The temperature measurement system, as I said, is a linear system. It's still hard to see in this picture. It's over here. It's a metal, stainless steel cable, and within the cable are two fiber optic cables, which are influenced by the temperature, and the deflection of the light that occurs in it is a measurement for the temperature. The detection zones are 15 meters, so there are two temperature measurements within one sprinkler zone. That's the configuration as we use in this system. Now, how do we activate a system like that? And actually, it's like a simple recipe. The basic principle, it's detect the fire, determine its location, activate ventilation, and sprinkler. Sounds like a plan to me. And if we take a little closer look, and we have a typical section of the tunnel here, you can see the sprinkler sections and the detection zones. Now, in case of a fire, of course, the temperature will heat up and eventually will give an alarm in the detection system. Now, based on this alarm, the control system will determine its location or its position relative to the sprinkler sections, and the first sprinkler section will be activated at that position as well as two adjacent sprinkler sections. And this is to cool down the environment surrounding the fire. And it's good to know that the sprinkler is designed actually to protect the tunnel lining and to protect the tunnel's construction. So about 40% of the sprinkler water is reflected back to the tunnel lining to cool down the tunnel structure as such. Now, at the same time, a ventilation system is started and a fourth sprinkler section. Now, the ventilation system is used to force the smoke and the hot gases within a certain direction and through the two, actually, sprinkler sections behind the fire position. Now, this being about 60 meters, and the spray density must be enough to cool down the hot gases, so when they exit the last sprinkler zone, the temperature of those gases will be below 360 degrees. This is the basic principle. But now, is there a catch? Well, basically there's always a catch, so also in this case. And that's that we have a position detection fault in case of a wind speed already in the tunnel. We found out during those tests we performed, and we performed those tests in all 5 tunnels, that when we have an airflow or a wind speed that is 2 meters a second or higher, this is not what will happen. Actually, the heat is transferred with the airflow, and the detection will take place further down, so in the direction of the airflow. Now, although we still want the sprinkler to be activated on top of the fire, the control system will, if it just looks at the alarm position the fire in that direction. And as a result of that, the total sprinkler position will be moved downstream. And as you can see, you already have less coverage on this side of the fire. Now, on top of that, and it was already mentioned this morning, there's a second effect because of the wind, and that's that the water will be blown away as well. And in the test we performed, we saw that it could be between 15 and 30 meters. And now it's a bit exaggerated in this picture, but you see that you have a very bad coverage on this side of the fire. So what to do? We need a correction. And we found this correction actually in the temperature measurement and the profile of the temperature. What you see in this graph is the temperature, so from 0 to 70 degrees, and these are the measurement points within the tunnel. So each 15 meters we have a measurement point. And this curve, this profile, is actually a snapshot of that temperature data taken at the moment that the alarm is given. So that's when the highest temperature reaches a threshold and the alarm is given. Now this is for a rather small fire. It was estimated to be about 0.5 megawatt, and we hardly have any wind, so 0.2 meters a second. Now, but when there's more wind, it's a total different ballgame. If you look at this profile, that's taken at 2.4 meters a second, and that was a test with a bigger pool fire, 4.5 megawatts, and you already see the difference in the profile. You should already see the shift as well. And if you take a closer look at this particular profile, it's obvious that we have a wind from that side. And what we saw with all tests performed with a higher wind speed, we get data like this. And then you see you have a steep rise of the temperature on the upside of the wind, and you have kind of a tail at the downside. Now, what you also see is that in the black curve, I don't know if you noticed, the temperature goes down almost to ambient temperature again. That was about 12 degrees. But here it stays higher. And you have a very distinct difference between the temperature on this side and on this side. And that's what we use now. At the point in time that the alarm is raised, the control system will take the data, take that snapshot, and will calculate the temperature difference on both sides of the maximum. And if that reaches a certain value, and in our case we estimated it to be 20 degrees, and if it's higher, the difference is higher than that, the control system will draw the conclusion that we have a wind and that we need correction. And it will then correct to the side of the maximum where the temperature is the lowest. So based on the temperature curve, we can estimate the wind direction and also give a rough estimate of the wind speed itself. Now, how does the activation sequence look in this case? Well, here we have our fire again. We have the shift and we have our wind. Now, let's presume it's the same curve as I showed you before. So the control system will take that snapshot at this point in time, and it will calculate a severe temperature difference. What it will do then is that it will correct the position, and it knows which way to correct it. And based on this new position, the first sprinkler section will be activated. And even now, if you still have the effect of the water being shifted, you see that you have enough coverage on the upwind stream side of the fire. And that's what you actually want to have in these cases. So this brings me to the end of my presentation. And well, I introduced you to the Betuwe Route in the Netherlands, and as Mr. Covalent said this morning, there has been a lot of discussion about these sprinkler systems and activation, and if an engineer on the train would survive. But we estimated that he would, so it came in. We looked at the actual firefighting system, so the principle and the basics behind it, how we use the sections, 30-meter sections and the detection system to come up finally with a correction if needed because of wind speed. And this brings us back to the question I raised at the beginning of my presentation, if it's possible to do a correct activation of a sprinkler system. And to my experience with these systems, I really do think that automatic activation is possible. Thank you for your attention.
Thank you very much.